All right, now we're going to talk about the geometric. And these ones are usually a little more new for people. So you are going to want to make sure you write these down, the geometric properties of equality. So we have three. The first one is called the reflexive property. Basically, I think about a mirror, like you're looking at your reflection. It's just saying that the same, whatever you have is equal to itself. So A equals A. If you have a line segment, AB equals AB, because it's the same thing. If you have an angle, the measure of angle A equals the measure of angle A. So that's the reflexive. Okay, symmetric. Symmetric is basically you're changing, it's kind of like the commutative property, you're changing the order. So reflexive is kind of the self. Symmetric, you change the order. So if A equals B, then B equals A. All right. Transitive is a little more complex. It's kind of like a chain. If A equals B, like if A and B are both 2, and B equals C, B and C are both 2, then you can say that A equals C. Okay? All right, so this is actually example 4 because we skipped one. We're going to practice making a proof with our geometric properties. So I would say, what do you need? I would draw the diagram. Okay, I would draw the diagram and I would write the question. Determine whether the measure of angle DBA equals the measure of angle EBC. Okay. All right, so let's go ahead and set this up. So we're still going to set up a table, okay, with equation, explanation, reason. Okay, so if we look at this diagram here, what do we know? What are they giving us in the problem? If you see these markings, we know that angle 1 is congruent or equal to angle 3 because they have the same like one line. If they both had 2, they'd also be congruent. So that's how we know that. So I'm going to go ahead and write for my first line that the measure of angle 1, okay, equals the measure of angle 3. Okay, that was marked in the diagram. And that was given. So always start with what was given. In a geometric one, it might be from a diagram. In an algebraic one, it would be sort of just the equation. All right, next, let's think about what else we know. Because we're trying to prove or determine whether DBA, so we're trying to prove if this is equal to EBC. So that's our ultimate goal. Let me erase this because it's just getting kind of crowded on here. So what do we know? Let's think about DBA. I'm going to make that blue. So here's D, here's BA, DBA. What do we know about that? I would say we know that the measure of angle. Okay, so we know that DBA is equal to angle 3 plus angle 2. Okay, we're just adding adjacent angles. And I don't know if you remember this from I think section 1.5, that's your angle addition postulate. Right? When you add two angles, it's equal to the sum. Okay. Okay, then let's basically do the same thing on the other side for angle DBA. Okay, what else can we know? If we know that angle 1 is congruent to angle 3, let's use some substitution here. So I'm going to say that the measure of angle DBA equals angle 1 plus angle 2. So what did I do right there? I substituted angle 3 with angle 1 because up here in this line they're equal. So that was substitution. Substitute, and that's your substitution property of equality. You know what, I'm going to write that out so you don't think it's subtraction. Okay, then let's go ahead and do the other side. So what do we know about the other side? Okay, we know that angle 1 plus angle 2 is also equal to EBC. Angle 1 plus angle 2 is also equal to EBC. Okay, and that's basically just like line 2. We added adjacent angles. And we use the angle addition postulate. Okay, then if we know that angle, I'm going to highlight it so maybe you can see a little better. If we know angle 1 and angle 2 are equal to DBA, and we know over here that angle 1 and angle 2 are equal to EBC, what can we then conclude? What can we conclude? We can conclude that the measure of angle DBA is equal to the measure of angle EBC. And what property? Go back and look at your geometric ones if you need to. Okay, that's your transitive property. I'm going to skip the explanation. Okay, we have one last example, example 5. We will be drawing a diagram for this one, and then you can kind of figure out what you want to write as well. All right, let's figure out what we have here. A park, a shoe store, a pizza shop, and a movie theater are located in order on a city street. So it's like Robert Street. Okay, you got a big street with all this commercial stuff on it. The distance between the park and the shoe store is the same as the distance between the pizza shop and the movie theater. Show that the distance between the park and the pizza is the same as the distance between the shoe store and the movie theater. So let's draw a picture, figure out what we have going on here. So let's see, let me get my pen out here. So let's start with the park. Okay, here's the park. We've got a big long street here. We have the park and we have the shoe store. Okay, we have the pizza shop. And the movie theater. Oh, sorry, the handwriting is so messy. Okay, and it says the distance between the park and the shoe store is equal to the distance between the pizza and the movie. Show that the distance between the park and the pizza, so from here to here, show that that is equal to the distance between the movie theater and the shoe store. All right, so let's go ahead and I need a little space for this. Let's go ahead and set up our table. So we're going to have equation, explanation, reason. Okay, so, and I'm going to go ahead and maybe use some letters here just to make this a little easier. So I'm going to call the park P. I'm going to call the shoe store S. I'm going to call the pizza, since I don't want to have two P's, I'm going to call it Z. And I'm going to call the movie theater M. Okay, so what do we know? We know that from the park to the shoe store, so P to S. okay, is equal from the pizza shop, Z, to the movie theater, from here to here. Okay, that's marked in the diagram, and that was given to us in the word problem. That says marked, given. All right. All right, then we're trying to prove that the park to the pizza shop is equal to the movie to the shoe store. So what else do we kind of know here? Let's think. We know that from P, the park to the pizza, let me make that let's highlight that. From the park to the pizza, right? From here to here, highlighted in yellow. So that's PZ from the park to the pizza. That equals PS, right? From the park to the shoe, that equals this plus this. Okay, we're just adding some segments. That is your segment addition postulate that lets you do that from lesson 1-2. Okay, and we can say the same thing for this side. Okay, we can say that from SM, from the shoe store to the movie theater. Oops, I'm on highlighter still. So SM equals SZ from the shoe to the pizza plus ZM. Same thing, we're just adding segments, and we're also using the segment addition postulate. I'm going to use some symbols for that. Okay. All right, then let's go ahead and add SZ to each side. So let's say PS plus SZ equals ZM plus SZ. So where did I get all this from? I got this from up here. I took the first statement, and just like an equation, right? If I add 2 and add 2 to each side of my equation, it will be equal. So I took that original equation and I added an SZ. I added the same thing to each side. So I added SZ to each side. Okay, since I'm adding, that's my addition property of equality. All right, then I'm just going to do some substitution. So since SM equals SZ plus ZM, I can then say PZ equals SM. So I substituted PZ for PS plus SZ. Let me highlight that. Okay, let me highlight this so I show you what I did. So I substituted PZ. So I'll make it green. I substituted PZ right here for PS plus SZ. Okay. And I can do that because of right up here. So I'll write that out. Substitute PZ for PS plus SZ. Okay, and that's my substitution property. So my goal with this problem is that hopefully you were able to kind of follow along. Not necessarily that you'd be able to come up with this proof yourself independently, but that you would be able to fill in the blanks in the table with sort of a word bank type thing for this example. For the equations, like example 1 and example 2, those I would expect you to be able to do on your own. Okay, so for the summary, why are the properties of equality helpful? What do they let you do? They let you solve equations, they let you prove things. Why are they helpful? Even though they might be annoying to write out in a proof. Lastly, summarize in your own words the geometric properties. So that's just the geometric, not the algebraic. So that's the reflexive property, the symmetric property, and the transitive property. Then there are some homework problems, and the nice thing about the homework is it will have like drop downs and drag, so it will kind of help you as you work through learning how to write a proof. So it will be very helpful, I think, to use the Big Ideas app. All right, you can always hit me up for questions. I know this is kind of a new skill and a new way of thinking, and it's not very traditional, doesn't have a very traditional math feel to it. Thanks for watching. Have a great day.